If there's one thing the Metal Gear Solid series knows how to do, it's confuse the bejesus out of me. No, don't get me wrong though, I love it. But what is with that vampire guy who can run on water, those robots that move... Oh yeah, and that man made of bees.
Dr. Bees!
No, not him.
Bees?
Okay, maybe it wasn't bees. Hornets, whatever. What was his deal?
We are the sons of the boss!
Anyway, I'm a bit of a science nerd. I know, you're shocked. So one central theme from the Metal Gear series that has always appealed to me is the origins of Solid and Liquid Snake. Specifically the fact that they are both clones of Big Boss, the legendary soldier and protagonist of Ground Zeroes. So, could we actually clone Big Boss using modern science in real life? Les Enfants Terribles, a United States government project designed to create two clones of Big Boss, the so-called twin snakes, Solid and Liquid. Why? Well, as the story goes, Big Boss was rendered sterile due to radiation exposure during a nuclear test, and the top brass in charge didn't want to lose all his incredible soldier genetics should he happen to die. So they decided to clone him, and to do this, they used a technique called somatic cell cloning. Okay, so far so good. Now, exposure to radiation can indeed cause someone to become sterile, and somatic cell cloning is a real thing. Although more accurately it's known as somatic cell nuclear transfer. Now the technique requires two things. Number one, a somatic cell from the person you want to clone. Now this is any cell in the body really containing DNA other than an egg or a sperm. Now, these are known as germ cells. And number two, an unfertilized egg cell from a donor. First off, the nucleus of the egg cell, that's the part that contains all of the DNA, is removed and discarded. Then, the nucleus from the somatic cell is transferred to the waiting egg. So now we have an egg containing all the DNA it needs to divide, grow, and eventually become a living thing. All that needs to happen next is a few chemical nudges to get the process going, and then a ready and willing surrogate mother to have the egg embedded in their uterus for 9 months. Now, because DNA is the blueprint for the living thing, the resulting child will be genetically identical to the donor of the somatic cell. Okay, now this is a bit of bonus science because technically a clone is not 100% genetically identical to the original. The reason is because of mitochondrial DNA. So what's that? Well, mitochondria are tiny little energy factories which sit inside the cytoplasm of our cells. They also have their own DNA, which, by the way, is always passed on by our mothers, as the egg is where the mitochondria live. So, in the world of Metal Gear, while Big Boss would have the mitochondrial DNA of his natural mother, both Solid and Liquid Snake would have the mitochondrial DNA of the egg donor. Now, in real life, this technique has been used to clone a number of different animal species. On the list of successes we have Dolly the trend-setting sheep, cows, pigs, mice, and even rare creatures like Gaur and Mouflon. Yes, these are real animals. But what about humans? Well, it is a bit complicated. Now, there are almost certainly no cloned humans walking around in the world today. However, just last year, a team of scientists did successfully create a cloned human embryo through this somatic cell nuclear transfer. The reason was to use this embryo as a source for embryonic stem cells, which are invaluable in the development of new medical research and treatments. So, while there are no cloned humans alive today, this research further demonstrates that there's nothing impossible about human cloning. It would, however, be both messy and tricky. You see, cloning is not a precise or reliable science, to say the least. Even today, animal cloning is still fraught with failure. The majority of embryos don't survive, and most of those that do make it to pregnancy result in miscarriage. So if you were going to clone a human, it would result in a large number of failed attempts and take a really long time. However, credit to Metal Gear Solid lore, it does mention that there were numerous failed attempts during Les Enfants Terribles project. So overall, as the science goes, the series is pretty much spot on with the cloning of Big Boss. There are, however, a ton of legal and ethical reasons why not to, mind you, but that's a discussion for a different show. Okay, so while it is possible, would cloning a super soldier actually mean that the clones are also great at being soldiers? Well, not necessarily. Now, I don't want to get sucked into a whole nature versus nurture debate at this point, but the fact is that as humans, we are a product of both our genetics and our environment. So sure, Big Boss might have a load of genetic traits on his side which helped him to be a badass soldier, perhaps higher than average muscle mass, say, or increased oxygen carrying capacity of the hemoglobin in his blood. But that said, it doesn't mean the clone of a gifted soldier will necessarily be equally good at soldiering. At most, you could say they are predisposed to being a great soldier. But ultimately, training and upbringing are absolutely crucial when it comes to developing strength, skill, and intelligence. All cloning really does is rewind to time zero and then start again. The environment then begins to affect the clone in entirely new ways, resulting in a different person, even if genetically they would be identical. Okay, but what about the negative side effects of cloning? In Metal Gear Solid 4, we clearly see Solid Snake suffering from accelerated aging. But is this actually a problem with real-life cloning? Well, Dolly the sheep, the first mammal to be cloned, did die at a young age of just 6. Usually sheep of the same species live twice that long. At the time, the blame was levelled at Dolly's telomeres, which were shorter than they should have been for a sheep of her age, a telltale sign of premature aging. So what's a telomere then? Well, they're little bits of DNA that have been compared to the little plastic tips you get on shoelaces. That's because their job is to keep chromosome ends from fraying and sticking to each other, which would destroy or scramble an organism's genetic information. However, since Dolly's death, many cloned animals have gone on to live lives of a normal length, casting doubt on premature aging being an unavoidable side effect of cloning. In fact, just last year, researchers from the Riken Center for Developmental Biology in Kobe, Japan, identified a way to produce healthy mouse clones that live a normal lifespan and can also be sequentially cloned indefinitely. So, what do you think of this episode and the idea of human cloning? Let me know in the comments box down below or by tweeting directly at me at CamFrazRob. Last week on Reality Check, I investigated the science of getting in the zone while playing a game, also known as cognitive flow. Subsequently, I was helpfully sent a bunch of great resources for further reading by Dr. Nick Bowman, Assistant Professor and Research Associate at the Media and Interaction Lab at West Virginia University. Check out his work if you want to learn more about this fascinating topic. The links are on screen now. Thanks, Nick. Okay, that's it for this week. Thanks for watching, and see you back here next Sunday for more Reality Check.